Let's now see the first application of pointers, which is with function parameters. So here I have shown problems with the normal parameter passing. So if I do pass parameters normally without references or without pointers, what happens is, see, if I pass the parameter x here, and if I change inside the function, if I do x equal to x plus 5, and once I call the function, and if I try to print the x, what I am going to get is same value 10. The changes are local to this variable x. This x is copied here, right? There are two different x variables, right? So whatever change you make to this x, they are not reflected to this x. So you get the value as output as 10. So this is one problem. If you want to change the value, you cannot change it without references or pointers. And when do we need to change the value? For example, if you're writing a swap function, which is supposed to swap two variables, right? So I can't write swap function without references or pointers. Let's see the second problem with the normal parameters. If I pass a string to a function, and if I pass it without using pointers or references, what will happen is this whole string object, right? This S string object here, it will be copied to this local string to this function, right? So there are two copies of the string created, right? And our intention was to just print the string, say in this function, maybe do something minor things, right? And this whole string is unnecessarily copied. And not only strings, in actual software development, you have large objects. For example, if you are making a college software, there might be a student object which contains lots of data, right? So with normal parameter, the whole thing is copied whenever you call the function, and we can avoid this by using references and or pointers. So we have discussed references examples in the earlier video. Please pause this video and try to use pointers to fix both the problems. Here are the modified codes, and now I am using pointers in both the codes. In this code, I am passing address of a variable x, right? And I am receiving it in a pointer variable, right? So when I use ampersand before a variable name, it gives me the address. So I pass the address and receive it as a pointer variable. This is how we declare pointer variables, right? So this is p is local to this function. See, I have changed the name from x to p just for readability purpose. You can name the pointer variable as x also, because this x and this x, they are different. This x is local to this function, this x is local to this function, right? So we receive it as a pointer, and now we go to that address using dereference operator. We get the value at that address and we change it to a star p plus 5, and this way we are able to change the value of x, right? Value of x, which was 10 here, after the function call you are going to get the value of x as 15, because we passed the address of x. We received it in a pointer variable. Using the dereference operator, we change the value at this address, right? Value at this address is current value at this address plus 5. Let's now see the second modified code. In this code, I am again passing a string using pointer, right? So I receive this pointer variable and I print star s. And when I pass the string, I pass the address of the string variable. So what is the advantage here in the second example? The whole string is not copied. We are simply passing the address of the string object. This way we avoid copying of this whole string.